Welcome to Sleepy Galaxy Studio. Tonight, we're going to slow science down. Not to make it smaller, but to make it gentle. We're drifting toward the Andromeda Galaxy, a quiet neighbor in the dark, a soft glow that doesn't ask for your attention. It simply exists. If your eyes want to close, let them close. If your thoughts feel busy, let them soften. You don't need to remember anything tonight. You don't need to follow every detail. This is a calm space documentary designed for sleep. Steady pacing, soft narration, and a gentle background that stays out of the way. Some episodes include an optional, very low 432 Hz tone, kept extremely subtle beneath the ambience. If you don't notice it, that's fine. If you do notice it, let it remain in the background like a quiet hum. There will be no harsh sounds, no sudden jumps, no debate, just calm, evidence-based wonder. Before we begin, let the night feel simple. You are safe where you are. The story will move slowly, and nothing here requires effort. In a moment, you'll hear about dust lanes like soft shadows, about slow orbits that take the long way around, and about Starlight traveling patiently through space. But you don't need to hold on to any of it. You can let the information pass through you, the way a gentle breeze passes through a dark field. Take one slow breath in and a slow breath out. Good. Let the voice stay steady. Let the ambience stay soft. Now, we begin. Gentle from where we stand. If you've ever looked up under a truly dark sky, you know how subtle it feels. Andromeda rarely looks like a crisp spiral with clear arms. It appears as a pale smudge, a soft brush stroke of light. That softness isn't a flaw. It's what distance looks like when it reaches human eyes. At night, vision changes. In low light, your eyes become more sensitive, but less precise. They gather faint light and blend it, turning countless tiny points into a smooth glow. So when Andromeda looks like a gentle patch rather than a picture, your eyes are doing something wise, trading detail for sensitivity. You may also hear Andromeda called M31. It's simply a label from an old catalog, useful for pointing to the same object without confusion. The label doesn't add drama, it removes it. Now, what is Andromeda in the simplest sense? It is a galaxy, a gravitational home. A vast system where stars, gas, and dust move together in slow orbits. It has layers, bright regions, faint regions, and a wide structure that fades into darkness rather than ending sharply. If you imagine it from far away, imagine something stable and patient. A system where fast is still slow, and recent can still mean a very long time. Spiral galaxies have arms, but the arms are not rigid lines you could trace. They are patterns, regions where stars and gas gather a little more densely as everything orbits. Imagine slow currents in a wide ocean. Nothing abrupt, nothing loud, just gentle organization. Across Andromeda's disk, dark dust lanes form soft shadows. Those lanes are not empty gaps. They are places where dust blocks and scatters some of the starlight behind it. Dust in space is made of tiny grains spread across huge distances, but even tiny grains matter when enough of them sit along the line of sight. The result is simple. Parts of the globe become dimmer, and the galaxy gains quiet contrast. Where gas and dust gather, new stars can begin. Star formation is often described with dramatic words, but the real process is patient. A cloud cools. Gravity draws material inward. The center becomes denser and warmer until a new star can shine steadily. Even the birth of a star can be understood as a gradual transition. No rush, no sudden shock required. Andromeda holds many ages of starlight at once. Some regions are shaped by older stars with a warmer, softer glow. Other regions include younger, hotter stars that can appear brighter in certain observations. A galaxy is not a single mood. It is many eras layered together, sharing the same slow rhythm. Toward the center, the galaxy becomes brighter. This bright central region is often called the bulge. It looks brighter because the density of stars increases. More stars in a smaller area means more combined light, like a lamp seen through thin fog. Still gentle, but richer. Many large galaxies host a supermassive black hole at their core. That phrase can sound heavy, so we'll keep it calm. Most of the time, a supermassive black hole is quiet. It is not a roaming force, and it does not pull in everything. It is simply a deep gravitational feature, and the surrounding stars orbit in response, slowly, predictably, and patiently. In some observations, Andromeda's inner region can show an unusual appearance, sometimes described as a double nucleus. You don't need to treat that as a mystery tonight. It's a reminder that the distribution of stars near a galactic center can create surprising patterns of light, even when the overall system remains calm. Beyond the bright disk, Andromeda extends into a halo, faint, wide, and difficult to see without long exposures. The halo doesn't end sharply. It fades, little by little, until galaxy becomes night and night becomes galaxy. That soft edge is part of why Andromeda feels so suitable for sleep. It is large, but it does not insist on being seen. Andromeda is not alone. It has companion galaxies, including M32 and M110. Each companion is its own system of stars, its own quiet story, moving in relation to Andromeda's gravity. If you imagine them, imagine quiet lanterns drifting near a larger glow, separate, but connected by the same calm pull. Together, Andromeda and the Milky Way belong to a small collection called the Local Group. You can picture the Local Group as a quiet neighborhood of island universes, several galaxies traveling together through space. Not crowded, not noisy, just a gentle community held by gravity. When you look at Andromeda, you are also receiving light after it has traveled. You don't need to turn that into a number tonight. Let it be a feeling instead, a gentle far away, a soft delivery of light that arrives without urgency. Different kinds of light reveal different aspects of a galaxy. In visible light, dust lanes stand out as soft, dark shapes. In infrared, older stars can become more prominent, and dust becomes less blocking. In radio observations, astronomers can trace cold hydrogen gas extending beyond the bright starlight disk. One galaxy, many windows, each one calm in its own way. Andromeda also carries a simple lesson about scale. The distance between stars inside a galaxy is vast. Even in denser regions, stars are separated by enormous space. So a galaxy is mostly space, mostly quiet. The light is real, but the structure is airy and wide, like a mist made of suns. Now, let your attention soften again. You don't have to hold every detail. You can keep only the feeling. A wide, steady structure in the dark. A glow that arrives gently. A system that changes slowly enough to feel timeless. Take one slow breath in and one slow breath out. In the next chapter, we'll keep things practical and peaceful. How Andromeda is found, why it disappears under city light, and how the night teaches you to see faint things without forcing them. And we continue, softly. In this chapter, we'll keep everything practical and peaceful, not as a checklist you must follow, but as a calm way to understand why Andromeda often reveals itself only when you stop trying too hard. Most people meet Andromeda through a photograph, a bright spiral with sharp dust lanes and glittering star clouds. But the sky does not look like a photograph. The sky is subtle, and Andromeda is subtle too. That's not a disappointment. It's part of the calm. Under dark conditions, Andromeda can appear as a faint glow. Under bright city lights, it can vanish completely. Not because it's gone, but because the background sky becomes too bright for your eyes to separate faint contrast. City light lifts the brightness of the sky itself, and the faint objects live on contrast. So the first thing to remember is simple. You don't need a better galaxy. You need a darker background. If you ever step outside to look for Andromeda, the first step is time. Give your eyes a chance to adapt. 10 minutes helps. 15 is better. 20 can feel like a small transformation. As your eyes adjust, your pupils widen, and your sensitivity increases. The sky deepens. More stars appear, and the faintest structures begin to feel possible. The second step is lowering the expectation of what seeing a galaxy means. You are not looking for a crisp spiral. You are looking for a soft patch, a pale smudge, a presence that is only slightly brighter than the sky around it. This mindset changes everything, because when the mind expects a dramatic shape, it misses subtle reality. But when the mind expects subtlety, the subtle becomes visible. If you use a star map app, keep your screen dim. A bright white screen can reset your night vision quickly. A red tint helps, but the key is brightness. Dim is kinder to your eyes. Dim lets the darkness stay intact. Now, there's a technique that feels like the opposite of effort. It's called averted vision. In low light, your eyes can detect faint objects better when you don't stare directly at them. If you look slightly to the side of where the glow should be, the galaxy can become clearer. It's not magic, it's biology. Your peripheral vision is often more sensitive in darkness. So instead of staring into the smudge, you glance beside it. And the smudge becomes more confident, a little more present. Still soft, but unmistakable. Sometimes it appears, disappears, and then appears again. That doesn't mean you imagined it. It means your visual system is adjusting moment by moment, and faint light sits near the threshold of perception. Another gentle method is slow scanning. If you sweep your gaze slowly across the area, faint contrasts can pop out. A glow becomes noticeable because it changes relative to the background as your eyes move. A fixed stare can make the glow feel invisible. A slow scan can make it quietly present. If you can reduce local glare, do it. Turn off nearby lights. Step into shadow. Use a hood or a hat brim to block stray light. Small changes can give you back contrast, and contrast is the real currency of faint objects. Binoculars help because they gather more light than the naked eye. They don't transform Andromeda into a dramatic picture, but they make the glow more obvious and more stable. A telescope can reveal more, but it can also narrow the view. For Andromeda, a wide view is often more satisfying. The galaxy is large across the sky, and context matters. Low magnification can keep the galaxy inside a larger, calmer frame. If Andromeda looks slightly elongated, that's normal. We see its disk at an angle, not face on. Tilt turns a circle into an ellipse, and the edges fade rather than stop. That fade matters. Galaxies don't end with hard borders. They thin out. They dissolve into darkness. And that softness at the edge is part of what makes Andromeda feel peaceful. Now, soften the science behind why this works. In bright light, your eyes rely more on cones, cells that give sharper detail and color. In darkness, your eyes rely more on rods, cells that are more sensitive to faint light but less precise. So at night, your vision becomes a tool for sensitivity rather than sharpness. That's why Andromeda becomes a smooth glow instead of a crisp spiral. And this is why the sky rewards patience. Faint things reveal themselves when you stop demanding clarity. Another quiet detail is the moon. A bright moon can wash out faint contrast, even far from city lights. Haze and humidity can brighten the background as well. So the best nights are often simple: clear air, low glare, and as little moonlight as possible. There's a calm observing routine many people end up learning naturally. They step outside, they breathe, they let their eyes adjust. They choose one small region of the sky to visit slowly, not hunting, not rushing, just spending time. Because faint objects appear best when you give them time to appear. And that is the gentle conclusion of this chapter. Seeing Andromeda is less about power and more about softness. Soft eyes, soft expectations, soft attention. Now, let your attention return to the sound of this voice. Let the details become background. Let the calm remain foreground. Take one slow breath in and one slow breath out. Good. In the next chapter, we'll drift deeper into Andromeda's structure, the disk, the dust lanes, and the calm physics of Starlight. And we continue. Now we move closer to structure, still gently, not in a way that demands focus, but in a way that lets the mind drift while the story stays steady. When you see images of Andromeda, one feature often stands out first: dust lanes. They look like dark rivers crossing a pale glow, and it can feel surprising that dust can do that at all. Space dust is made of tiny grains, silicates, carbon-rich particles, and frozen compounds. Individually, each grain is almost nothing. But across enormous distances, those grains can build up along the line of sight. And when enough dust sits between you and a bright region of stars, it dims the light. Not dramatically, softly, like a thin veil. Dust lanes are not empty. They are not holes. They are places where material gathers, gas and dust together. And where gas and dust gather, star formation can follow. To understand why, imagine a calm, cold cloud. A region of gas that has cooled enough to begin collecting. Gravity gently pulls inward. As the cloud contracts, the center becomes denser. Over time, dense pockets form. And inside those pockets, new stars can ignite. This doesn't happen like a sudden flash. It happens like a gradual turning on, a slow rise from cold to warm, from diffuse to organized, and then steady light. In Andromeda, as in many spiral galaxies, star formation often traces the spiral pattern. Not because the arms are solid objects, but because the pattern helps organize material. Gas spends more time in certain regions. Density increases slightly. And those small changes over long time can be enough. Now picture the disk of Andromeda, a broad, tilted plane of stars. We don't see it face on. We see it at an angle, which stretches its shape into an ellipse. In that disk, starlight is layered. Some light is close to the surface, some is deeper, and dust sits like a soft filter between layers. That filtering is why Andromeda can feel so textured in photographs. Bright regions and dim regions, smooth glow and soft shadows. It is not harsh contrast. It is quiet contrast. Beautiful because it isn't trying to impress you. Andromeda also contains regions dominated by older stars. Older stars, on average, produce a gentler, warmer glow. They are steady. They don't announce themselves. They simply continue. You can think of a galaxy as a place where many different times overlap. Young stars in one region, old stars in another. Gas drifting, dust gathering, everything moving slowly in orbits that repeat. And those orbits are one of the most calming ideas in astronomy. Because an orbit is a promise of repetition, a return, a cycle that doesn't need urgency. Stars orbit the center of their galaxy over very long timescales, and as they orbit, the galaxy keeps its general shape. Not perfectly, galaxies evolve, but slowly enough that the change feels like weather in a deep season rather than in a single day. Now imagine Andromeda's outer disk. The brightness fades gradually as you move outward. Galaxies do not end abruptly. They thin out. They dissolve into the dark. Beyond the disk is the halo, faint, wide, and hard to see with the eye. The halo can hold older stars and traces of a long history. Sometimes it holds streams, faint arcs of stars that were gently pulled from smaller companions over time. These features remind us that galaxies grow, not always by sudden collision, but by slow gravitational rearrangement. A small galaxy drifts near. Orbits shift. Stars are drawn into new paths, and the evidence remains faintly like a soft signature. If this sounds complex, you can let it be simple again. The simplest truth is this: gravity shapes matter slowly, and slow shaping creates structure. Dust lanes, star-forming regions, a bright center, a fading edge, a wide halo. The whole system feels like a calm machine of time, built from light. Now, because this is sleep science, we keep the tone gentle. No fear, no urgency, no dramatic framing. Just the quiet idea that even the largest structures in the universe are organized by patient forces, and that patience can be borrowed. If thoughts appear, let them pass. If you catch yourself trying to hold the picture, let it soften. The goal is not to visualize perfectly. The goal is to rest while the story continues. Take one slow breath in and one slow breath out. Good. In the next chapter, we'll drift into the local group more deeply, placing Andromeda among its neighbors and exploring the calm idea of distance without turning it into pressure. And we continue, softly. Now we widen the view, gently. We've been close to Andromeda, its glow, its dust lanes, its slow structure. In this chapter, we place it in its neighborhood, not as a dramatic story and not as a competition, just as a calm map of where it belongs. Astronomers call this neighborhood the Local Group. It's a small collection of galaxies that share the same general region of space, held loosely by gravity. Not crowded, not noisy. More like a quiet archipelago, separate islands of light traveling together through a wide, dark ocean. Andromeda is one of the largest members of this group. The Milky Way is another. There are also smaller companions, fainter galaxies that drift nearby, each with its own quiet structure. The calming part is this: even a group of galaxies is mostly emptiness, mostly distance, mostly silence. The galaxies are not packed together. They are separated by vast space, and they move slowly. When you imagine the local group, imagine patience. Imagine long time. Imagine motion that takes the long way around. Now, it can be tempting to turn this into numbers, to ask exactly how far, exactly how fast, exactly when. But tonight we don't need that. We can treat distance as a feeling, a gentle far away. Distance makes light soft. It thins intensity. It turns something enormous into something quiet. That's why Andromeda reaches you as a whisper. In the local group, gravity is the quiet organizer. Gravity doesn't shout. It doesn't rush. It simply shapes motion over time. Galaxies drift because of gravity, but they also carry their own internal motion. Stars orbit within them. Gas circulates, dust gathers, spreads, gathers again. So there are two kinds of movement at once: the movement within a galaxy and the movement of the galaxy through space. Both are calm when you look at them on the right timescale. Now, let's bring this back to something soothing. A group of galaxies is like a slow dance, not a fast one, not a performance. More like a gentle turning, where partners have plenty of room, and the music is barely audible. The Milky Way, our own home galaxy, is a spiral galaxy too. We live inside it, which means we can't step outside and see its full shape with our eyes. But we can still understand its structure through careful observation. Stars, gas, dust lanes, and a wide disk. In that sense, the Milky Way and Andromeda share a family resemblance. But they are not identical. Each galaxy has its own distribution of stars, its own dust structures, its own quiet history of growth. Similar patterns, different stories, like two slow songs in the same key. Andromeda also has companions that orbit nearby. You can imagine them as small lanterns traveling around a larger glow. They are not decorations. They are separate systems made of stars moving under gravity. Sometimes, over long time, smaller galaxies can be pulled apart. Their stars can become streams, faint trails that wrap around a larger galaxy. If you've seen images of these stellar streams, they look delicate, almost like silk threads in darkness. And that delicacy is accurate, because in space, even dramatic events can leave gentle shapes. This is an important mood for sleep science. The universe can be complex without being aggressive. It can be dynamic without being loud. Now, when people talk about the Milky Way and Andromeda, they sometimes frame it as a future event. But tonight, we keep it soft. We keep it slow. We keep it non-dramatic. The useful idea is simply that galaxies are not frozen in place. They move. They respond to gravity. And on long time, their paths can bring them closer. That isn't a reason for fear. It's a reason for calm perspective. Because the timescales are so large, they are not part of your daily life. They are not part of your night. They are not urgent. And that's exactly why this topic can help sleep. It gently reminds the brain, not everything is immediate. Not everything requires action. Some things unfold slowly enough to be almost like background. Now imagine this. Imagine the local group as a dark room. In that room, there are a few distant lamps. Each lamp is a galaxy. They glow softly, far apart from one another. And between them is space. Quiet, wide, and still. You can picture Andromeda as one lamp, the Milky Way as another. A few smaller lamps around them, faint but real, and the rest is calm darkness. If your mind tries to hold the picture tightly, let it loosen. You don't need sharp edges. You don't need precise placement. You only need the feeling of a gentle map. There is also something comforting about membership. We are not isolated in the universe. We belong to a neighborhood, a quiet one, but a real one. And yet, the neighborhood is not crowded. There is plenty of room, plenty of distance, plenty of silence. Now, bring your attention back to the sound of this voice. Let the facts become background. Let the rhythm become foreground. One calm breath in and a calm breath out. Good. Before we move on, one last gentle point. When scientists study galaxies, they use many different kinds of light. Visible light shows dust lanes and starlight. Infrared can reveal older stars and see through some dust. Radio can map cold gas. Each wavelength is like a different way of listening. And this is a beautiful thought for sleep. The universe is not just something you see. It is something you can study with patience, from many angles, without forcing it to be simple, and without forcing yourself to stay awake. So in this chapter, we place Andromeda where it belongs, in a calm neighborhood of galaxies, moving slowly, held quietly by gravity, with distance that softens everything into a whisper. Now, let that settle. Take one slow breath in and one slow breath out. In the next chapter, we'll drift into the quiet idea of light itself. How starlight carries information, how it travels, and why that journey can feel like a lullaby. And we continue. Now we drift into a quiet idea that feels almost like poetry, but is also pure science. Starlight is a message. Not a message with intention. Not a message written for us, but a message in the simplest sense. Information carried gently across distance. Every night, light arrives from places that do not know we exist. And still, that light carries clues. It carries the story of temperature, of motion, of matter. It carries patterns that can be read without force, without urgency, with the same patience that sleep requires. When we say starlight, we often imagine a single thing, a single white sparkle. But light is more like a wide language. It comes in many wavelengths, many colors, many energies. Some of it your eyes can see, some of it you cannot. And yet, it is all part of the same quiet stream. The first gentle message in light is brightness. Not as a competition, but as a clue. Brightness can tell us something about how much light is being produced and how far that light has traveled before it reaches us. Even without numbers, the concept is soothing. The light arriving here has been softened by distance. It has been thinned, stretched, and diluted into calm. Another message is color. Color is not decoration. Color can be a thermometer. Bluer light can suggest hotter stars. Redder light can suggest cooler stars. And a galaxy is not one color, because it is not one kind of star. It is a layered mix, young and old, hot and cool, bright and faint. When you look at a galaxy's glow, you are seeing a blend of many lives at once. But the most powerful message in Starlight is hidden in detail we don't see directly. It is hidden in the spectrum. A spectrum is what you get when you spread light out, like a soft ribbon from one end to the other. When you do that, you can find lines, dark lines or bright lines, embedded in the ribbon. These lines act like fingerprints. They show which atoms and molecules are present in the light source, or in the gas the light passed through on its way. It's quietly astonishing. A thin line in a spectrum can tell you that hydrogen is present. Another line can suggest helium. Others can hint at elements forged in stars over long time. Nothing about this needs drama. It's just a calm fact. Light carries signatures, and the way those signatures shift can also carry a message about motion. When something moves away from you, the light can be stretched slightly. Its features shift toward the red end of the spectrum. When something moves toward you, the features can shift the other way. This is not a human invention. It is simply how waves behave. So in Starlight, there is a gentle message about movement. Not fast movement you must react to, but slow cosmic motion that unfolds over long time. Now, bring this back to Andromeda. When Andromeda's light reaches us, it has traveled through space that is not perfectly empty. It passes through thin gas. It passes near dust. And dust can change the message subtly. Dust can dim light. Dust can scatter shorter wavelengths more efficiently than longer ones. That can slightly redden the light that arrives, like a soft filter. So even the space between us and a galaxy becomes part of the message. Not a barrier, just a gentle influence. Telescopes, in this sense, are translators. They are not only magnifiers, they are collectors and interpreters of messages. A telescope gathers more light. That makes faint things clearer. But instruments attached to telescopes can also separate light, measure it, and record it. They can listen to the universe in ways that are quiet, exact, and patient. Different telescopes listen to different parts of the light language. Some focus on visible light. Some listen in infrared, where dust becomes less blocking. Some listen in radio, where cold gas can be traced. Some look for ultraviolet, where very hot processes leave signatures. Some detect X-rays, where energetic regions speak softly but clearly. This is one of the most soothing ideas in modern astronomy. The universe does not have only one voice. It has many. And science is the practice of listening carefully. Now, think of time. When Starlight arrives, it is already history. You are not seeing a galaxy in a single now. You are receiving a message that left long ago and has been traveling since then. This does not have to feel heavy. It can feel like calm perspective. A message traveling for a long time becomes gentle by the time it arrives. It loses urgency. It loses sharpness. It becomes a whisper. That whisper can still contain meaning. In Andromeda, the combined glow contains the blended message of countless stars. Some stars are older, steady, and warm. Some are younger, brighter, and more intense in certain wavelengths. Some regions hold gas clouds where new stars can form. Some regions are quieter, dominated by older populations. When scientists map these differences, they are reading messages. Not as entertainment, but as a careful way of understanding structure. Yet for sleep, we can keep the meaning simple. Light tells you that something is there. Light tells you that something exists beyond your room, beyond your street, beyond your city. Light offers the mind a larger horizon, and a larger horizon can soften worry. Now imagine this. Imagine starlight as a long, slow letter. Not written in words, but in patterns. Not delivered quickly, but delivered patiently. A letter that arrives without demanding to be read immediately. You can listen without analyzing. You can let the idea be gentle. Because the goal is not to do astronomy homework. The goal is to feel your nervous system slow down. There is also a comforting thought in the limits of human perception. Your eyes capture only a narrow band of the light language. Even so, you can still see Andromeda. Even with a small window, you can glimpse a whole galaxy. Science expands that window, but it does not remove the calm. It deepens it. Now, consider one more quiet message in light: stability. Many stars shine steadily for long periods. Their light is consistent enough to be measured, compared, and trusted. That steadiness can be felt. A steady signal is calming. A steady voice is calming. A steady background is calming. In this way, starlight fits perfectly into a sleep documentary. It is information carried gently. It is presence arriving softly. It is time delivered in calm. So in this chapter, we let one idea settle. Starlight is a message. It carries temperature, composition, motion, and history. And it carries them without urgency, without drama, without needing anything from you. Take one slow breath in and one slow breath out. Good. In the next chapter, we'll explore another quiet question: how we learn distance in space gently, without turning the night into a math problem. And we continue softly. Now we move into a topic that sounds technical, but can feel simple: distance. In everyday life, distance is obvious. You can walk it, you can drive it, you can measure it with a ruler, a map, a timer. In space, distance is different. You cannot step outside to measure it directly. So astronomy learned a gentle skill. It learned to infer distance from light. This isn't guesswork. It's careful listening. And it happens in layers. The first layer is geometry. If you view something from two different positions, it can appear to shift slightly against a background. In daily life, you see this when you hold up a finger and close one eye, then the other. The finger seems to jump against the far background. Astronomy uses the same idea with Earth's orbit. As Earth moves, nearby stars shift slightly relative to very distant stars. That tiny shift can be measured with patient instruments. And from that shift, distance can be inferred. This method is calm and honest. It doesn't depend on opinion. It depends on slow observation and geometry. But Andromeda is far beyond this first layer for simple direct shifting. So astronomy uses additional layers, still based on light. Another layer is standard candles. A standard candle is not a literal candle. It is a kind of object whose intrinsic brightness can be known or inferred. If you know how bright something truly is, and you measure how bright it appears, the difference gives you distance. This can sound like a formula, but the feeling is simple. Light fades with distance, so brightness becomes a clue. One of the most famous standard candles is the Cepheid variable star. Cepheid variables pulse. They brighten and dim in a regular rhythm. and the rhythm relates to their true brightness. If you observe the rhythm, you can infer how luminous the star is. Then you compare that true luminosity with the observed brightness, and you infer distance. This is one of the quiet miracles of astronomy. A star's gentle heartbeat becomes a ruler. Cephids were essential in understanding that Andromeda is a galaxy beyond the Milky Way, not a small cloud inside it. A pulsing star, observed carefully, helped expand the known universe. Now, there are other standard candles too. Some stellar explosions, like certain supernovae, can serve as extremely bright distance markers. They can be seen from far away, and their light curves carry information. But tonight, we keep it soft. We don't need every detail. We only need the calming structure. Astronomy builds distance like a ladder. One method supports the next. Each step is grounded in observation. Each step adds reach. This ladder has a name, the cosmic distance ladder. And the metaphor is perfect for sleep. Because a ladder is not a leap. It is step-by-step progress, built on stability. Now consider Andromeda again. We do not need to picture it as a number away. We can picture it as far enough to be gentle, far enough that it becomes a faint glow, far enough that it arrives as a soft smudge, far enough that its details require patience. Distance, in this sense, is not a barrier. It is a filter. It turns intensity into calm. And distance also creates time depth. Because if light takes time to travel, then distance also means you are receiving an earlier chapter of reality. Not because the source is frozen, but because the message has a travel time. Again, no numbers required. Just a feeling. Far away equals softly delayed. There is also a psychological comfort in the way science handles uncertainty. It doesn't pretend to be perfect. It measures. It cross-checks. It improves. It refines. In sleep content, that attitude matters. It means we can share science without arguing, without forcing certainty where it doesn't belong. We can stay calm and honest. Now, bring your attention back to the body. Distance can feel abstract, so we make it gentle. We let it be a story of light fading and time passing. We let it be a quiet reminder that not everything is immediate. One calm image can help. Imagine Andromeda as a lighthouse across a still sea. Not close enough to be loud, not far enough to be gone. Just far enough to be soothing. The beam reaches you, thin and quiet. You don't rush to decode it. You simply notice it. And noticing it is enough. And this is the soft truth of astronomical distance. It is not only measurement, it is perspective. It widens the mind's horizon. It reduces urgency. It makes today's problems feel smaller without denying them. Because when the universe becomes wider, the nervous system often relaxes. Now take one slow breath in and one slow breath out. Good. In the next chapter, we'll let time become gentle too. How galaxies carry history in their stars, and how we can read that history calmly. And we continue, softly. Now we let time become part of the story, because space and time are connected through light. Distance creates travel time, and travel time means that astronomy is, in a quiet way, a study of history. When you see Andromeda, you are not seeing it in a single instant. You are receiving light that has traveled. So you are always receiving an earlier chapter of its story. This doesn't need to feel strange. it can feel soothing, because it means the night sky is full of long timelines, and long timelines reduce urgency. A galaxy is not a snapshot. It is a slow process. Stars are born. Stars change. Stars end. And the ingredients they release can become part of new stars. Over long time, galaxies become layered with different generations. That layering is visible in the populations of stars. Older stars tend to be different in their composition than younger ones, because early stars formed when there were fewer heavy elements available. As time goes on, stellar processes enrich the environment, and later generations form with slightly different ingredients. Astronomers sometimes describe this as metallicity, where metals means any element heavier than hydrogen and helium. We don't need the term tonight. We can keep it gentle. The universe becomes more chemically rich over time, because stars act like slow furnaces. So when we study a galaxy's stars, we are reading time. We are reading which eras are present in which regions. In Andromeda, different parts of the galaxy can reflect different histories. The bright central region holds a dense population, often dominated by older stars. The disk can hold both older and younger populations, and regions where star formation has been more recent. The halo can hold very old stars and faint streams, traces of long interactions. This is not a loud story. It is a quiet one. A story written in faint light and gradual change. Now, think about the halo again. A halo can carry memory. Faint arcs of stars can remain as gentle evidence that smaller systems once passed nearby, and gravity slowly reshaped their paths. This is how a galaxy can grow. By slowly gathering, slowly blending, slowly reorganizing. Andromeda's companions also add to this sense of history. A companion galaxy is a separate chapter drifting nearby. Over long time, gravitational relationships can change, and the sky's structure can evolve. Again, for sleep, we keep this soft. No fear, no urgency, no dramatic framing. The most soothing takeaway is simply that the universe changes slowly. So slowly that change often looks like stability from a human timescale. And that stability is calming. Now consider another quiet aspect of time: rhythm. Cepheid variable stars pulse with a rhythm. Other variable stars pulse too. These rhythms are steady enough to be measured. The universe contains repeating patterns, and repeating patterns are comforting to the brain. They signal predictability. They signal order. Even the rotation of a galaxy is a kind of rhythm. Stars orbit. Gas circulates. Dust gathers. The pattern holds for a long time. When you imagine a galaxy rotating, imagine a slow turning. Not a fast spin. A calm, steady motion that takes the long way around. Now bring the focus back to Starlight. Starlight carries history, but it also carries the present of the source, as it was when the light left. So in a way, Starlight is always a bridge, connecting there to here, and then to now. This bridge can feel like a lullaby, because it invites the mind to drift. It invites the mind to stop gripping the immediate. It invites the nervous system to widen its sense of time, and a wider sense of time reduces urgency. Now, a gentle image. Imagine Andromeda as a quiet city of light in the distance. Not a city you must enter, but a city you can simply notice. Its lights have been on for a long time. They have been changing, slowly. Some neighborhoods grow brighter as new stars form. Some neighborhoods become calmer as stars age. The whole city evolves, but the change is gradual. You can let that image float. No need to hold it tightly. Now, return to the body again. Feel the weight of your shoulders. Feel the softness of the air. Let the story stay outside you, and let your body stay here. One slow breath in, and one slow breath out. Good. In the next chapter, we'll explore a calmer kind of fossil in space. Star clusters, and what they can tell us without being loud. And we continue, softly. Now we drift into something small, but deeply informative. Star clusters. A star cluster is a group of stars that formed from the same cloud, around the same time, with similar ingredients. Because they share an origin, they can act like a gentle reference point for studying a galaxy. There are different kinds of clusters. Some are loose and young, still near the regions where they formed. Others are old and dense, bound tightly by gravity. These older, denser clusters are often called globular clusters. Globular clusters can contain very old stars. They orbit in the outskirts and halos of galaxies, and because they are ancient, they carry memory. Not memory like a storybook, but memory like geology, a record of early conditions. If you imagine a globular cluster, imagine a small swarm of lanterns. Many lights packed into a tight space, moving together, held by gravity. And yet, even inside a cluster, the distance between stars is still vast by everyday standards. Space remains spacious, even when it is dense. Globular clusters can help astronomers estimate ages of stellar populations, because stars evolve in predictable ways over long time. The cluster becomes a living diagram of stellar lifetimes. Again, we don't need equations tonight. We only need the calm concept. Stars change slowly, and groups of stars provide clues because they share a timeline. Andromeda has many globular clusters. Studying them helps scientists understand how Andromeda formed and grew. Some clusters may have formed within Andromeda. Some may have been acquired from smaller systems over a long time. In either case, the clusters remain as quiet evidence. This is one of the most peaceful themes in astronomy. The universe leaves traces. Not dramatic scars, gentle traces. Now consider open clusters, looser groups of stars. These are often younger and found more in galaxy disks. They can be associated with spiral patterns and star-forming regions. They are like fresh chapters compared to the older, deep-time chapters of globular clusters. So within a single galaxy, you can find both. Young clusters that reflect recent star formation, and old clusters that reflect early eras. A galaxy becomes a layered archive. Now, why is this soothing for sleep? Because it reinforces a calm kind of order. Not rigid order, but natural order. Stars evolve. Groups of stars form together. Galaxies collect these groups. And over long time, structure emerges. It's a story of patience. Now imagine observing a globular cluster through a telescope. It may appear as a tight, luminous ball. With more light and better resolution, it breaks into individual points. A cluster is a reminder that what looks like a single glow can contain countless separate lights. This mirrors Andromeda itself, a soft patch that contains innumerable stars. The same principle repeats, and repetition is calming. Now, another gentle idea. Clusters can also trace motion. If you measure how clusters move, you can infer the gravitational environment of a galaxy. Their orbits can hint at unseen mass distribution. Again, we don't need debate tonight. We keep it simple. Motion reflects gravity, and gravity shapes structure. Andromeda's clusters, along with its streams and companions, make the galaxy feel like a living system, not a static object. Now, bring the mind back to a soft image. Imagine a wide, dark ocean. In the ocean, a large, faint glow, Andromeda. Around it, small islands of light, clusters, and companions. Everything moving slowly, everything quiet. Let the image drift. No need to sharpen it. One slow breath in, and one slow breath out. Good. In the next chapter, we'll move into another messenger of structure, gas, and the quiet language of radio light. And we continue, softly. Now we listen to a part of the universe your eyes cannot see, radio light. When many people hear radio, they think of human signals, music, voices, broadcasts. But in astronomy, radio waves are part of the natural language of the cosmos. They can be produced by cold gas, energetic particles, and magnetic environments. They can travel through dust more easily than visible light, and they can reveal structure that would otherwise be hidden. One of the most important radio signals in astronomy comes from hydrogen, the most common element in the universe. Neutral hydrogen can emit radio light in a very specific way. This signal is sometimes called the 21-centimeter line. The name is technical, but the idea is gentle. Hydrogen can produce a consistent, identifiable radio signature. By mapping this signature, astronomers can trace hydrogen gas in and around galaxies. This matters because gas is the raw material for future stars. So gas maps can show where a galaxy has the potential to form new stars, and how far the galaxy's gaseous disk extends beyond the bright starlight disk. This is calming because it reveals a deeper layer of reality. What looks empty is often full of faint material. What looks finished is often still becoming. In Andromeda, radio observations can show that gas can extend farther than you might expect from visible images. The bright disk is not the whole story. The galaxy has a wider, quieter presence. Radio observations also help measure motion. If a signal shifts slightly in frequency, it can reflect motion along the line of sight. This allows scientists to map rotation and dynamics, even in regions too faint for optical detail. Again, for sleep, we keep this gentle. No math, no urgency. Just the calm idea that the universe can be listened to in many ways. There is also something soothing about radio astronomy as a practice. Radio telescopes often sit in quiet landscapes. Wide dishes turned toward the sky, listening. Not shining, not projecting. Listening. Listening is a restful action. It matches the mood of this channel. Soft attention, patient reception, a steady flow of information. Now imagine Andromeda again, but not as a picture. Imagine it as a pattern of signals, a structure that can be mapped through different kinds of light. Visible glow for stars, radio glow for cold gas. This multi-layered understanding makes a galaxy feel less like an object and more like a system, a living arrangement of matter and motion. And if you find that idea too detailed for sleep, you can simplify it to one line. There is more there than you can see. That single line can calm the mind because it expands perspective without demanding effort. Now let's bring the focus back to a quiet image. Imagine a faint, luminous island, Andromeda. Around it, an even fainter sea of gas, extending softly beyond the visible edge. The starlight is the surface. The gas is a deeper layer. Everything connected by gravity. Everything moving slowly. One slow breath in and one slow breath out. Good. In the next chapter, we'll take a calm tour across multiple wavelengths. How different kinds of light reveal different gentle aspects of the same galaxy. And we continue, softly. Now we take a gentle tour across different kinds of light, not as a technical lecture, but as a calm way of understanding why the same galaxy can look so different, depending on how you listen. In visible light, Andromeda appears as a soft glow with dark dust lanes. Visible light is the part your eyes know best. It shows the combined starlight that reaches us, and it makes dust lanes stand out as quiet shadows. In infrared light, the view can change. Infrared can pass through some dust more easily than visible light. It can also highlight older, cooler stars that contribute strongly in infrared. So an infrared view can feel smoother, less interrupted by dust, more like a broad, gentle structure. Ultraviolet light can highlight very hot, young stars. It can emphasize regions where star formation has been more active. But tonight, we do not treat this as excitement. We treat it as a calm difference. Different light reveals different ages. X-rays can highlight energetic environments, hot gas, compact objects, regions where matter is heated strongly. But even here, we do not chase drama. We simply acknowledge that a galaxy is not only quiet starlight. It can also contain energetic processes, most of which remain far away and not personally urgent. Radio waves, as we explored, can map cold gas and large-scale structure beyond the bright disk. So when you combine these views, you get a layered understanding. Stars, dust, gas, motion, and history. It's like hearing the same melody, played by different instruments. The tune is the same. The texture changes. Now, for sleep, the most helpful idea is this. Reality has layers, and you are allowed to notice only one layer at a time. You can let the detailed layers remain in the background. You can keep only the feeling of a galaxy as a soft system, studied gently through patient listening. If your mind begins to wake up with curiosity, you can soften it by returning to the simplest version. Different kinds of light show different parts of the same quiet truth. Now imagine Andromeda as a calm sculpture. Visible light shows the surface. Infrared shows deeper warmth. Radio shows hidden structure. Each view is like moving a lamp around the sculpture and noticing new contours without changing the object itself. One slow breath in and one slow breath out. Good. In the next chapter, we'll bring the focus back to the human practice of astronomy. Not as hustle, but as patient observation, and why that patience pairs so well with sleep. And we continue, softly. Now we step gently into the human side of this story, because astronomy is not only about galaxies, it is also about patience. To study faint things, you slow down, you wait, you reduce noise, you listen carefully. That practice is the opposite of modern urgency, and that is why it can soothe the nervous system. Many astronomers, professional and amateur, learn quickly that the best observations begin before the telescope. They begin with the environment. They choose darker locations. They reduce glare. They protect night vision. They let the eyes adapt They give themselves time. Time is the tool. And in a way, the brain learns to adapt too. At first, the sky feels blank. Then it becomes filled. Then it becomes layered. The act of waiting becomes part of the science and part of the calm. There is also a gentle discipline in recording what you see. Not for social media, not for performance, for clarity. Astronomy encourages careful notes, repeated observation, and cross-checking. This is science as a quiet habit, not a loud identity. In sleep content, that matters, because the tone stays grounded. We can enjoy wonder without exaggeration. We can share information without argument. We can remain calm even while discussing something immense. Now, consider how an observatory works. It gathers light. It reduces vibration. It filters noise. It records carefully. It protects the signal. That is also what good rest does. It reduces noise. It protects the signal of the body. It restores balance. So the practice of astronomy mirrors the practice of sleep. Both are forms of gentle alignment. Now, if you have ever looked at the sky and felt small, that can be soothing too. If you interpret it kindly, small does not mean unimportant. Small can mean unburdened. Small can mean free from the need to control everything. The sky offers that lesson naturally. It invites the mind to loosen its grip. One slow breath in and one slow breath out. Good. In the final chapter, we'll bring everything together in a calm recap. Not as a test, but as a drift. A soft closing that lets you fall asleep inside the larger perspective. And we continue softly. Now we arrive at a quiet ending. Not an ending that snaps shut, but an ending that fades like starlight at the edge of a galaxy. Tonight we met Andromeda as a soft presence, a faint glow that is real, even when it feels subtle. A galaxy large enough to hold countless stars and gentle enough to arrive as a whisper. We learned that seeing faint things often means softening, letting your eyes adapt, letting your expectations relax, using patience instead of force. We drifted through structure, a bright center, a wide disk, dust lanes like soft shadows, and edges that fade into darkness rather than ending sharply. We widened the view to the local group, a quiet neighborhood of galaxies, held gently by gravity, moving slowly enough to feel timeless. We listened to Starlight as a message. Information carried without urgency, patterns embedded in color and spectrum, history delivered softly across distance. We touched the idea of distance and time, not as pressure, but as perspective. Far away becomes gentle. Long time becomes calm. We visited clusters as quiet fossils, and radio light as a way of hearing what eyes cannot see. We remembered that reality has layers, and science is the practice of listening carefully. Now you don't need to hold these ideas. You can let them go, because the purpose of this episode was never to keep you awake. It was to give your mind something calm to drift on, something wide enough to soften worry. So now we reduce everything to a simple image. Imagine a dark, quiet sea. Far across it, a lighthouse. Not calling you, not asking anything from you, just glowing steadily. That lighthouse is Andromeda. Its light arrives thin and gentle. It crosses distance without rushing. It reaches you without demanding. Now imagine the light fading at the edges, like a galaxy fading into its halo. No sharp border, no hard stop, just gradual softness. Let that gradual softness become the mood of your body. Shoulders heavy, jaw relaxed, breathing slow. If thoughts appear, let them pass like thin clouds across a dark sky. No story needed, no effort. Just the voice, the soft background, and the feeling of a larger perspective. One slow breath in, and one slow breath out. Good. Andromeda remains, quiet and distant, patient and real, and you remain here, safe, resting, allowed to sleep. Now the final minutes can be simple. No new details, no new concepts, just quiet repetition of calm ideas. A galaxy is a soft system of light. Distance turns intensity into gentleness. Time turns urgency into perspective. Listening is enough. A galaxy is a soft system of light. Distance turns intensity into gentleness. Time turns urgency into perspective. Listening is enough. And as the voice continues, you can drift. You can let the words become a gentle texture. You can let the night carry you. Good night, and keep drifting softly.